we're now going to look at the first of the videos on indices, and this really is for basics, and this is something that you should be absolutely fluent with before you start. A to the m multiplied, and again I'm using my dot for multiplication, multiplied by a to the n leads to a to the m plus n, and then when we're dividing, a to the m divided by a to the n is going to give us a m minus n. These are an absolute given, and it will be assumed that you can do them at ease. So if we're multiplying in the base, remember this is the base and this is the power or the exponent. If the base is the same, all we need to do is add the powers. And a nice way of showing this is 2 squared multiplied by 2 to the power of 3. We know we're going to add their powers, so it's going to become 2 to the power of 5. We could write this out as 2 multiplied by 2, this part, multiplied by 2, multiplied by 2, multiplied by 2. 2 is the base, and that's the number of them that we've got. So a to the m multiplied by a to the n is a m plus n, and then the division, we subtract them. So let's quickly flick through. We've got here, we're multiplying, so we're going to add the powers, so we'll get 2 to the power of 11. This one, again, we're adding the powers. The base is the same. We add the powers. Here, what have we got to do? Well, we've got 4 to the power of 2 plus multiplied by 4 to the power of 4 is going to be 4 to the power of 6. Division, we subtract. 14 minus 10 is going to be 4. So this is all the basic stuff you would have done lower down the school. Now, one of the major areas that can often get people is the following: 3 multiplied by 3 to the power of 3. Something along those lines, and they end up with 3 to the power of 3. Because they don't see the little 1 on here, and it's hugely key that we have this 1. Okay, so we end up getting 3 to the power 4. Okay, and the 0 power, hopefully we know if we've got a 0 power, the 0 power is 1. And we'll quickly look at why that is. Okay, if we take the powers of 2, 2 to the power of 5 is going to be equal to 32, 2 to the power of 4 is equal to 16, 2 to the power of 3 is equal to 8, 2 to the power of 2 is equal to 4, 2 to the power of 1 is equal to 2. Now, as you can see, we're dropping down by a power each time, and we're dividing by 2. So logic says if we got 2 to the 0, then we need to divide by 2 again, and it gives us 2 to the 0 is equal to 1. And this is a general result. A to the 0 power is equal to 1. If we did it with 3, 3 to the 4th is going to give us 81, 3 cubed is going to equal 27, 3 to the power of 2 is 9, 3 to the 1st is 3, therefore 3 to the 0, we need to divide by 3 again, divide by 3, divide by 3, divide by 3, and we get 1. So anything to the 0 power is 1. So multiplying, we add the powers, which we should be called with, and divide, we subtract. So let's have a look at this. 2 plus 0 plus 4 is 6, 3 to the power 6. 2 to the power 6, 2 to the power 7, and 2 to the power of 1. 6 plus 7 is 13, plus 1 gives us 14. With these ones, if we look at it, we could simplify, or you could simply add the powers and subtract. 2 plus 4 is 6, minus 3, 7 to the 3rd. So we've got nothing different here. We could write that one out here as 7 to the power of 2, multiplied by 7 to the power of 4, divided by 7 to the power of 3. If you wrote it out in long form, you'd end up having 7 multiplied by 7 on the 7 squared, multiplied by 7, multiplied by 7, multiplied by 7, all over 7 multiplied by 7, multiplied by 7. And you know these are going to cancel. We can cancel the common factors. And you can see now we're left with 7 to the power of 3 over 1. So hopefully this is very much something you already know, or just simple revision. So if we're now working with the general form, a to the power of n multiplied by a to the power of n, we simply add the powers. A to the power of 5, a to the power of 10, x to the power of 9, division, we subtract. X to the power of 4 minus x to the power of 2 is going to give us x to the power of 2. 3 plus 0, y cubed, so y to the power of 3. Subtract the powers. And again, this form, b to the 6 divided, this is exactly the same form, we're just putting it now in a different, using different notation. b to the 6 divided by b to the 0. 6 minus 0 is 6, so we end up with b to the power of 6. Okay, so let's just finish off with some slightly more challenging ones. So with this one, let's just ignore the numbers to begin with. P to the power of 2 multiplied by p to the power of 5 is going to be adding the powers. P to the power of 7, 2 times by 4 is going to give me 8, 8p to the 7th power. We've got x, x and x, second power, third power and fifth power, so we add them up and it's going to come to x to the 10th. Now this one, a couple of different ways of looking at this. We've got 12n to the 7th, and I like to do it like this, 12n squared. You know that 12 and the 2 will cancel to give us 6 in the numerator, and now we're simply subtracting the powers, so it would be n to the power of 5. If you wanted, you could try and factorise this to get your head around it. You wouldn't do this, but I'm kind of showing you what this is actually telling us. 12 is going to be 2 times by 2 times by 3 times by n 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 times by n, and we need one more, which I'll write this side, and that's all over 2 times by 2 times by n, and I'll put the n this side. So this will start cancelling off, and what we'll have, that one can cancel with that one, which will cancel to that one, which will cancel to that one, and we're now left with the following. So what you'll see here is that the 2 and the 2 can go. So I've added another 2, haven't I? Didn't need that one. We'll keep the 2 there. 2 times 3 times by n times by n times by n, and we've ended up with the 5 n's there. You would never do this, but if you're struggling to see how that has come about, that's one way of looking at it. Let's look at this one. If we put this on top, 6x to the 5th, y to the 8th, all over 3x squared y, and if you need, y to the 1st. This will cancel down to give us 2. X to the 5th divided by x squared will give us x to the 3rd. We're subtracting the powers. 8 minus 1 is 7, so we get y to the 7th. These are first two rules of indices. In the next videos we'll look at the slightly more challenging ones. Okay, if you look at let's have a look at this one. Now, a few ways you can look at this. If you want to look at it crosswards, what we've got is 6 times by 2/3. Now, 6 times by 2 is 12, divided by 3 will give me 4. I've got an a to the 4th and an a, remember that's a to the 1st. So we're going to get a to the 4 plus 1, which is a to the 5th. B to the 5th multiplied by b cubed will give me b to the power of 8. And again, we will move on to this notation in the next part in terms of the power to a power. But essentially that's it. Take home message, a to the m multiplied by a to the n is a m plus n. A to the m divided by a to the n is a m minus n. And I've shown the long form of expanding this out, which you would never do. You would never do this, but it gives you some idea of what's dropping off in terms of common factors. So there we go. In the next video we'll do the slightly more challenging rules of indices, but that must be absolutely concrete before you move forward.